Hi everybody, my name is Paul Muntian and today I will talk about IntRepair, a tool for repairing integer overflows and in C source code. This is joint work between colleagues from TU Munich, KTH Royal Institute of Technology and Nanjing University. First of all, detecting and finding integer overflows in C source code is a hard problem, and as we can see in this example here, data is multiplied by 2 and potentially the result cannot be held in the variable result such that this can overflow. In a nutshell, our methodology is as follows. The source code is fed into our symbolic execution component. Overflow is detected. Then a repair is built. The repair is then validated. Then we perform target automated repair. Another step. Then we generate the code and we insert the repair in the original code. Then we recheck again if the repair was successful. In that case, we have a correct repair, the bug was removed, and we have an artifact which has no bug. Otherwise, the bug was not removed and the source code still contains the bug. In a nutshell, it's very important to understand how our tool selects the repairs. So as you can see in this example, statement is fed in, and depending on the operators and types, it selects from the number of currently repair which we currently have in our tool. As for now, we have more than 300 repairs, and the tool suggests then at the end the patterns which make more sense. The main idea of our approach is that we fuse fault localization and repair generation phases into a single algorithm via SMT solving, and the steps are based in determining the integer upper bound, generating an SMT constraint system, selecting constraint values, recomputing the bound checking constraints, determining the fault type, selecting repair pattern, as previously mentioned, determining the new constraint system, and generating the code repair. Further, in this picture, you can see how an integer overflow is repaired. In the left, at line 33 and 34, we have the original program, and if the user clicks on the bug icon, the middle image, then the source code will be surrounded by this if-else branch, which represents the code repair, which fixes the bug in this case. So with respect to our results, we use the largest integer overflow test suite from NIST, and we also synthesized more than 50 programs which have more than 20,000 lines of code. So with respect to fault detection effectiveness, we tested with all programs, and we were able in more than 2052 programs to detect all the integer overflows. And for the large programs, we had some timeouts. Further, with respect to fault removal, for all cases in which we successfully found the integer overflow, we were able to generate repairs which eventually resolved and fixed the bug. Further, with respect to performance impact, as you can see, for large programs which have 20k lines of code, the analysis time is under 10 minutes, which is very similar to other static analysis tools. The binary blowup is under 1%, 0.56%, and the execution overhead in average is under 2%, 1.57. Further, with respect to program correctness, we implemented here a number of steps and automation in our tool to verify that the repairs are correct, and we can testify that that all repairs are actually correct and preserve program behavior, the intended one. With respect to effectiveness, with respect to comparing our tool with manual repairs, we compare it with uh, we performed a use case with 30 participants. Half of them had access to the tool, the other half didn't have the access to the tool, and we measured the timings and how accurate they found and repaired the bugs. And we can say in conclusion that our tool, so the group which used IntRepair, is 10 times more effective in finding and repairing a bug. In summary, we presented IntRepair, a tool for detecting integer overflow and generating repairs which are also validated. We tested with more than 2000 C programs and more than 50 large um, programs. Our evaluation shows that the tool is very effective in determining the location of the bug and repairing them. And in a control experiment, we could show that our tool is 10 times more effective than repairing the bugs manually. So thank you very much. And if you have questions, please go ahead. Thank you.